Welcome to the Explainer. Today we're looking at an absolutely fascinating breakthrough in how we actually communicate with large language models. I was recently looking into how to squeeze every last ounce of reasoning capability out of a model, and I stumbled upon this brilliant technique from the latest prompt engineering research that basically flips traditional logic right on its head.
So, can artificial intelligence learn from its mistakes just like humans do? It's a pretty fascinating question, right? Because as humans, we don't exactly learn by doing things perfectly the very first time. In fact, we learn best from failure. We figure out what went wrong, we spot the bad logic, and we adjust our behavior for next time. But what if I told you we can teach large language models to do exactly the same thing? That we can actually make them significantly smarter by deliberately feeding them failure? No way, right? But it's true.
Okay, let's dive into this. Here's our roadmap for today. First up, learning from mistakes. Second, standard chain of thought. Third, enter contrastive prompting. Fourth, the prompt blueprint. And finally, automating wrong answers.
All right, Section 1, Learning from Mistakes. Let's start by drawing a strong connection between human psychology and machine learning. You see, a universal truth of learning is that knowing what not to do is just as critical as knowing what to do. Think about it. When we teach a person a new skill, pointing out a common pitfall helps them actively avoid it. And it turns out learning from negative examples isn't just a uniquely human trait. When we make large language models aware of what mistakes to avoid by explicitly showing them negative examples, their reasoning capabilities, and honestly their overall accuracy, improve drastically. They're able to generate much better explanations for their own answers because they have a clearly defined boundary of what bad logic actually looks like.
Moving right along to Section 2, Standard Chain of Thought. To fully appreciate this new upgrade, we first need to establish a baseline of how we currently prompt AI.
So the crucial point here is understanding standard chain of thought prompting. You might have actually used this. It's a technique designed to improve a model's accuracy on math and reasoning tasks by forcing it to, think before it spits out an answer. You can do this just by adding a simple phrase to your prompt, like, let's think step by step. Or you can provide a positive question and answer example before your actual question to kind of map out the desired logic. Now, this works incredibly well, for sure, but researchers realized it was really only giving the AI half the picture. It was totally missing the crucial element of contrast.
Which brings us to Section 3, Enter Contrastive Prompting. In November 2023, researchers from Damo Academy at Alibaba Group, the Singapore University of Technology and Design, and Nanyang Technological University introduced a massive paradigm shift.
They called it Contrastive Chain-of-Thought prompting. This is a game-changing technique that enhances an LLM's reasoning by embedding both positive, meaning correct, and negative, meaning incorrect examples directly into the prompt itself. By putting a flawed reasoning process right next to a perfect one, it creates this sharp, unmistakable contrast. It's like explicitly showing the AI the exact type of logical missteps to avoid, which powerfully guides the model straight toward the correct answer.
Okay, now that we know what it is, let's look under the hood. Section 4, the prompt blueprint. We're going to see exactly how to construct one of these contrastive prompts from scratch.
To build this, your prompt needs 4 mandatory components, and they have to be in this specific order. First, a sample question. Second, a completely correct explanation for that sample question. Third, an incorrect explanation for that exact same question. And finally, your actual query. Now, the true secret ingredient here is step number 3, the incorrect explanation. Why? Because it literally changes absolutely everything about how the model processes your final query.
And this brilliantly illustrates the technique in action. This is an actual math problem pulled straight from the research. So the sample question is about James, who writes a 3-page letter to 2 different friends twice a week, and it asks how many pages he writes a year. Look at the correct explanation on the left. It logically steps through the math, right? 3 times 2 is 6, 6 times 2 is 12 pages a week, 12 times 52 weeks is 624 pages a year. Flawless. Now take a look at the wrong explanation on the right. It deliberately jumbles the logic. It claims he writes 12 times 52 equals 624 pages a week and completely mixes up the operations to arrive at 12 pages a year. By feeding both of these to the AI before asking your real question, like in the research they use a real query about a dentist fixing 30 teeth, the AI studies this contrast. It identifies the structural errors in the wrong explanation and rigorously applies the flawless logic to your new problem. It's brilliant.
But we have to acknowledge a practical reality here, which brings us to Section 5, Automating Wrong Answers. Because let's face it, manually writing out incorrect math or flawed logic for every single prompt you ever want to run, yeah, that's incredibly tedious.
To solve this, the researchers devised an incredibly elegant, automated method to generate these contrastive examples. It basically works in 3 simple steps. Step 1, you curate examples with correct reasoning steps from an existing dataset. Step 2, you use an entity recognition model to scan that text and identify the key entities, specifically things like numbers, equations, or persons. And step 3, you simply shuffle the position of those extracted entities. Just like we saw in the James letter writing example, simply swapping the 52 and the 3 instantly creates a mathematically flawed but structurally plausible wrong answer. It is just an ingenious way to generate the perfect contrastive example right on the fly.
And honestly, the best news for developers and prompt engineers out there is that this automated code is entirely open sourced. You can find it right now on GitHub at damonlpsg/contrastive-CoT. This means you don't even have to build the automation from scratch. You can just pull this code and start implementing it into your workflows immediately to drastically boost your model's reasoning. So I want to leave you with this final thought to reflect on. If AI can master complex reasoning simply by studying our flaws, our bad math, and our logical missteps, what other human learning traits will it adopt next? Contrastive Chain-of-Thought proves that sometimes the absolute best way to teach a machine how to be right is to explicitly show it how to be wrong. Thank you so much for joining me for this explainer. I really hope this deep dive into contrastive examples leaves you inspired and eager to continue mastering the art of prompt engineering. See you next time.